Well, hey, living environment fans, it's that time again, that favorite time of the day when you get to come to my class and do the Bellringer. So let's do the Bellringer, and then we usually do, we have an ed puzzle video, and then we'll get to class.
All right. Hey now.
Mr. Kovacs class. It's Mr. Kovacs class.
You might learn a ton.
It's Mr. Kovacs class.
It's interesting too.
It's Mr. Kovacs class.
And he's super cool.
It's Mr. Kovacs class.
All right, we've been studying the chain link fence model of the cell membrane. Of course, in the real business, they don't call it a chain link fence. They say it's semi-permeable, because it allows some things to pass through easily, but other things have to be helped out on the way through. And that's what we've been studying, is the two ways that things are helped through the cell membrane, right? The cell membrane is semi-permeable. It's hydrophobic. It doesn't mix with water. Forms this nice waterproof barrier between the outside extracellular part and the inside of the cell, the intracellular. And semi-permeable, some things can pass through and some things can't. We've also discussed the cell membrane by what is called the fluid mosaic model. Okay? And what that means is that it's a fluid, so it's liquidy. The fats, the lipids are liquidy, and they keep moving around, and floating around in them. The mosaic part are proteins. Some of the proteins we've studied are either channel proteins or carrier proteins, or are used as pumps, like an active transport. Right. There's some other proteins we're going to talk about too that have a different job, and that's going to be today's topic. All right. By now you should know, in passive transport, the easiest way to do that is diffusion. This happens for small molecules like oxygen gas. Okay. Another passive transport is facilitated diffusion. That's where you want to move automatically, but you need help because you need a protein to let you through. Like water moves through facilitated diffusion. Sugars move through facilitated diffusion. And then the last type is called active transport, and that's when you go against the flow, right? And that requires energy, or energy of the cell, which is ATP, adenosine triphosphate. All right, so we've been studying the fluid mosaic model of the semi-permeable cell membrane found in eukaryotic cells. Listen to all that vocabulary you know. Right? Fluid mosaic model of the semi-permeable cell membrane, which is found in eukaryotic cells. Yeah, that's pretty sciencey right there.